Well, welcome. Again, my name is Mr. Murphy, and in this video we're going to be looking at lesson 6.6, all about exponential and logarithm equations and how to solve those. So let's go ahead and get started here. So the first step, today we're going to be looking at, again, solving exponential equations using a common base. And then we're going to learn how to rewrite exponential equations using logarithms and solve exponential equations using logarithms. So that's what we're going to be covering in this first day's lesson. Alright, so first off, the first property that we're going to look at is a property of equality for exponential equations. Now, this property looks pretty basic. In fact, it is pretty basic, but it allows us to be able to do the things that we're going to be doing here. But this is just showing us that if the bases are the same, so looking at the symbols here, by the way, may not make sense to you, but let's look at the words. It says if two powers of the same base are equal, then their exponents are equal. Or if two exponents are equal, then the powers with the same bases are equal. And you might be wondering, all right, how does that help me? Well, let's look at a situation like this. Where here we have 1/2 to the x plus 7 power equals 4 to the 3x power. And we're trying to solve for x. Well, the first step when we're trying to solve an equation like this is we want to, after writing the original equation, we want to rewrite each side of the common base. And so you might say, well, 1/2 and 4, how can we get a common base there? Well, let's start with the 4. Okay, the 4 is the same as 2 squared. And if you think back to our powers of exponents, knowing that we want to have a common base, I'm trying to figure out, well, how can I have a base of 2 with that 1/2? Well, hopefully after a while, maybe you remember that 2 to the negative first power would be the same as 1/2. And so now we have the same bases. We have, both sides have a base of 2. In the next step, we're going to use the power of power rule. Remember, these are all rules and properties that we've learned about in previous chapters even. So that just means that we're going to take those exponents and we're going to multiply them to each other. So we'd have that, in that first term there, we'd take -1 times both the x plus 7. So we'd end up with -x minus 7. And then with the base 2 on the other side, we would use that exponent of 2 times 3x and get 6x. And now we're going to apply that property that we just learned about, the property of equality for exponential equations. Again, you don't have to know the names of these. They're just showing us why it is we're able to apply each of these. And so now, since we have the same bases there, we could say that the exponents are also going to be equal to each other. So we didn't do anything to make those bases disappear. Okay, it's not like we divided by 2 or anything like that. All we're doing is by applying that property that says if the bases are the same, and we're saying that two sides of an equation are equal, that means the exponents must also be the same. Are you following that? So if the bases, so if I say that 2 cubed equals 2 to some exponent, well then that exponent on the other side has to be 3 because we're saying that those two are equal to each other. Okay, so it's the same concept there. So since the bases are the same, and we're saying that those two sides are equal, that means that the exponents must also be equal. So we're going to say -x minus 7 equals 6x. And now I just have a simple equation to solve. So we would add, we could add x to both sides. So we could get both x's on the same side. So I could add x to both sides. So now I'd have -7 equals 7x. And now clearly we would just divide by 7 to get our answer that x would equal -1. So I would encourage you, before you try one on your own, to go back and make sure that you understand each of those steps. But the next thing I'm going to have you do is I'm going to have you guys try these two problems on your own. So now if you feel confident enough, try these. Again, if you don't feel confident, go back and rewatch that video following each of those previous steps to make sure that you really understand how to do this and how to apply the different concepts that we've learned in this section and in previous sections to be able to solve for x. So go ahead, pause the video, and try to do as much of these as you can, and then hit play when you're ready to check your answer. All right, let's see how you did here. So let's start with the first one there. So the first thing I recognize is 25 is the same as 5 squared. And so my goal is to have a common base. And so with the 125, I'm trying to figure out, well, how can I make that with a common base of 5? Well, 5 cubed is 125. Right, so next step, just like the previous example, we're going to distribute. Okay, we're going to multiply those exponents together. So 2 times 3x would be 6x, and 3 times x plus 2 would give us 3x plus 6. Make sure you multiply both those exponents, the x plus 2, by the 3 there on that second side. All right, so now we have the same bases that are equal to each other. So now we can just say, well, the exponents are going to equal each other. So we'd have 6x equals 3x plus 6. We're going to solve that equation by subtracting 3x from both sides to get 3x equals 6. And then lastly, divide by 3 and you get x equals 2. All right, the second one that's above me here, this one's a little bit easier. As long as you remember that 0.001 is the same as 10 to the negative third power. A little easy trick. You move the decimal to the right 3 places to get to 1 whole. So 10 to the negative third power would be the same as 0.001. And then we'd have 10 to the 6x power. Okay, so that you don't have to do anything with that. We could just leave that alone. So now we have both sides are the same bases. So we can apply that property that we just learned about. And so we would say that the exponents would be equal to each other. So we'd have negative 3 equals 6x. Divide both sides by 6, you get negative 3 over 6, which reduces to negative 1/2. So how did you do? Hopefully you at least were able to start some of those, or maybe even after seeing how to start it with getting the same bases, maybe the rest of it you should be able to do on your own. All right, let's look at this next example. It says, how can you rewrite the equation 17 equals 4 to the x power using logarithms? Well, since you can do anything in algebra, as long as you do the same thing to both sides, you can also take the log of both sides. So this simple stuff will help with future problems. So we have 17 equals 4 to the x power, so to rewrite that with logarithms, we could just put a log in both sides. Literally, that's all you have to do. Log of 17 equals log of 4 to the x power. That's all you got to do. And like I said, that simple step is going to help us with some future problems. So I want you guys to go ahead and try this one on your own. 5 to the x power equals 12. How can you write that using logarithms? Hopefully, you're thinking, really, is this all I have to do? Yes, that's all you have to do for this one. So we'd have log of 5 to the x power equals log of 12. That's it. All right. So let's use this next property. This next property of equality for logarithmic equations says that as long as x is bigger than 0, then the log base b of x equals log base b of y if and only if the values of x and y are equal to each other. That's basically what that's saying. So how's that going to help us? Well, let's look at this problem. It says, what is the solution of 3 to the x plus 1 equals 5 to the x power? Well, earlier, what we learned about was trying to get the same bases. I can't get the same bases here. Okay, there's nothing I can do to 3. There's nothing I can do to 5, so we'd have the same base. Well, now what? Well, let's start by taking the log of both sides. Okay, what we just did a second ago. So we'd have log of 3 to the x plus 1 power equals log of 5 to the x power. And now, let's use some of those properties we learned about in lesson, the previous lesson, 6.5. So that x plus 1, that's an exponent, we can put that in front of the logarithm. And that x, that's an exponent for the 5, we can put that in front of the logarithm. Well, now we can use a distributive property, because over on the left side, we'd have log of 3 that we could multiply times both the x and the 1. So we'd have x times the log of 3 plus 1 times log of 3, which is be log of 3, equals the right side, x log of 5. Well, now we're going to combine like terms. Okay, so they combine 2 steps here in 1. So let's look at what they did here. On the right side, we have x log of 5. And on the left side, we have x log of 3, along with just a plain old log of 3. Well, what they did is they subtracted x log of 5 from both sides. So if you wanted to, you could have another step here that would say x log of 3 minus x log of 5, and then subtract log of 3 from both sides. So you'd have equals negative log of 3. Okay, you with me right now? So there's an invisible step right now where they would have x log of 3 minus x log of 5 here. Well, what they did is they recognized that both of those terms have an x, and so they factored out an x. So then we'd have x times log of 3 minus log of 5 equals negative log of 3. And what this is going to allow us to do is it's going to allow us to solve for x. Because to solve for x, we would divide both sides by the log of 3 minus the log of 5. Because that log of 3 minus log of 5 is going to be a number. And so if we divide both sides by that number, log of 3 minus log of 5, we would now solve for x. Well, the last thing we're going to do is we're going to do this on our calculator. So you got to be careful when you're doing this on your calculator. You want to make sure that if you do this all in one step, which if you're using a scientific calculator, I would not encourage you to do this in one step. I would encourage you to do this in 2 steps, meaning write down what negative log of 3 is on your calculator. So type in negative log of 3, write down that number. Use a bunch of numbers after the decimal. Use like 4 or 5 numbers after the decimal so you're more accurate in your final answer. And then do log of 3 minus log of 5. And then get that answer and write that down. And then divide those two values. Because otherwise, if you type in negative log of 3 and then divided by log of 3 minus log of 5, you're not going to divide. It's only going to divide the first term. It's only going to take negative log of 3 by the first term, not by the second term, not by the minus log of 5. So if you're going to do it all in one step, you got to use parentheses, but a lot of times people forget those parentheses, and then they get the wrong answer, and they don't realize they get the wrong answer. So I would encourage you guys to do it in 2 steps, so in that way you're going to be more accurate with your final answer. All right, so again, just like that problem that we did earlier, before we go to the next one, we're going to try this on your own. I would encourage you to rewatch this portion, so in that way you can see this example worked out one more time, and then you'll be able to try this one on your own. So again, if you need to, go back and watch that other example worked out. But if you're feeling confident, or if you've already done that now, I want you to try this example and see if you can figure out how to get your answer. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did here. Whoops. So the first thing you're going to do is you're going to take the log of both sides. Now I did this in 2 steps. Okay, if you want to do this, you can, because again, you don't have to describe what you're doing in each step. But what I did is I took the log of both sides, and I recognized that when I was going to take the log of both sides, that those exponents would also move in front of the logarithm. So I killed two birds with one stone. So I took the log of both sides, and I moved the exponents in front of those logs all in one step. You can do the same thing. All right, so then after you get to that point, then the next step is to, on the right side, distribute that log of 7 to both the x and the 1. So we'd have x times log of 7 plus log of 7. And now I want to combine like terms. And so on the left side, I have 3x times the log of 2. On the right side, I have x log of 7. So I'm going to subtract. So just like the book did, I'm going to do this in, again, 2 steps all in one. I subtracted x log of 7 from both sides. So I had 3x log of 2 minus x log of 7. But I recognize that both of those terms have an x. So I factor an x out. So we'd have x times x times the quantity 3 log of 2 minus log of 7 equals a log of 7 on the right. So I'm going to divide everything by that 3 log of 2 minus log of 7. And when you do that, again, doing that on your calculator, I'd encourage you to do that in 2 steps. You get approximately 14.57 when you round it to the nearest hundredth. All right, so hopefully you're able to do most, if not all, of those steps on your own. And if not, maybe you need to go back and watch some of those examples and just make sure that you understand every single step and how to do those. Otherwise, you guys, good luck. I hope everything made sense to you. And come to class tomorrow if you do have any questions.